This is R.D. Sharma Solution, Class 12th. Chapter 9, Continuity. Exercise is 9.1. Now here, at x equal to 1, we have to find whether this function is continuous or not. That is, the pathway or the road which I told you, whether it is broken or it is continuous. Okay. So how do we do this? At particular point x equals 1, first we'll check whether the value of this function at x equals 1, which is given in this question, is what? f1 is given as 2. This is the first thing. Then we will find out the limits, that is the left hand limit and the right hand limit. If the left hand limit and right hand limit are equal and it is equal to the value of this function at x equals 1, which is 2 in this case, then we say that this is continuous. So LHL and RHL will find out. So in place of x, what we are going to put? 1 minus h. Here we are going to put 1 plus h. 1 minus h, so it will not be equal to 1 then. X is not equal to 1. So we'll put it here. 1 minus h whole square minus 1 divided by 1 minus h minus 1. Here 1 plus h whole square minus 1 divided by 1 plus h minus 1. What this will be? A square plus b square minus 2ab. So 1 square plus h square minus 2h minus 1 divided by 1 minus h minus 1. You can cancel 1 1. You will get negative h. Here a square plus b square plus 2ab minus 1 divided by 1 1 gets cancelled, h it will be 1 1. You can cancel on both sides. This is h minus 2. I am taking h outside. Here also I am taking h common, so h plus 2 it will be. H you can get cancelled. Now negative I am taking up, in the numerator, so 2 minus h. Here 2 plus h. Now apply the limit, h tends to 0, so this will be 2. Limit, and both sides it will be 2 and 2. So what does it mean is that the left hand limit is equal to the right hand limit, which is equal to 2. They are equal, and this is also equal to the value of the function at x equals 1, which is 2. Okay, so this function is continuous at x equals 1. So let me show you how you are going to actually put up. That is, this is the formal way you are going to give the solution. This is how you are going to write. So this fx is now sine 3x by x when x is not equal to 0, and it is 1 when x is equal to 0. So we have to check at x equals 0. So don't worry about the graph of sine 3x by x, because it will be sine 3x we know already, sine x already we know the graph of x, but sine 3x by x will be different. Okay. So same criteria, same way, left hand limit, right hand limit, and at x equals to 0, that is fx. If x equals 0, it is going to be 1. So left hand limit, right hand limit, we would like to have this number 1. So LHL, RHL. And the point of contention or point of discussion is x equals 0. So what we are going to put it here? X will be equal to 0 minus h. X will be equal to 0 plus h. So I'll just change it. It is not 1 minus h. It has to be checked at 0. So 0 minus h and 0 plus h. Okay. So it is sine. So 0 minus h we have to, because it is 0 minus h, so we will take this case. So 3 0 minus h divided by, in place of h, 0 minus h. Here sine 0 plus h and divided by 0 plus h. So this is going to be sine minus 3h. Divided by minus h. Since it is negative, so you have to put a negative here. Sine minus 3h. Here it will be sine 3h divided by h. Now by trigonometry and trigonometric identities, equations, we know sine negative theta is negative sine theta. Because in case of cos theta, it's reverse. Cos minus theta is cos theta. But sine minus theta is minus sine theta. So we can write it as minus sine 3h divided by minus h. And minus minus you can just cancel. Here it is sine 3h divided by h. So divide and multiply both sides, both numerator and denominator, by 3 in both the case. So limit h tends to 0, sine theta by theta is nothing but 1. So sine this 3 numerator denominator both the cases. This is 3h. So sine 3h by 3h, limit both the cases, it is going to be 1. So only what is remaining here is, because 3 was already outside, so both ways it is 3 on left hand limit also and right hand limit also. But limit exists and the value is also same. But the value at x equals to 0 is 1. It is not equal to 3. That is why we can say that this function is discontinuous at x equals 0. Okay? They both are 3, but the value of the function at x equals 0 is 1. fx is equal to e raised 1 by x if x is not equal to 0, and 1 if x is equal to 0, whether f is continuous at x equal to 0. So fx equals f0. What is the value at 0? It is already given in the question, it is 1. So LHL, RHL, if it comes to 1, then it is continuous, otherwise it is discontinuous. So how do we do this? Remember, discontinuity and continuity is directly related to differentiability. So x equals 0 will check LHL, RHL. So what is left hand limit? It's x will put as 0 minus h, and on the right hand side we are going to put x as 0 plus h. So we'll use the first one because x is not equal to 0. Soon you put 0 minus 3 or 0 minus h, it's not equal to 0. So e raised 1 by 0 minus h divided by, there is nothing in the denominator, so you can just write on the right hand side e raised 1 by 0 plus h. So here e raised minus 1 by h, here e raised 1 by h. So you can write this e raised 1 minus h by 1 by e raised 1 by h. That is, if you write 1 by x, you can always write it as x inverse, x raised minus 1. So 1 by e raised 1 by h. Here we have e raised 1 by h. Okay, now we are ready to apply the limit. Limit is h tends to 0. Limit is h tends to 0. Okay. So when we get this e raised 1 by h tends to 0, if we apply 1 by 0 is infinity, so it is actually e raised to the power infinity, and e is a constant number 2.732, so we have a proper number. So it is to the power infinity, so that will be infinity only, and 1 by infinite, anything divided by infinite is going to be 0. Here also on the right hand side e raised 1 by 0, so 1 by 0 is infinity, e raised to the power infinity, same discussion, same logic, it is going to be infinity. Okay, so this is 0 and this is infinity, this is 1. So neither left and right hand limits are equal, nor they are equal to the value at x equals 0. So you can easily say it is not continuous, discontinuous. So same way here, let fx equals 1 minus cos x by x square when x is not equal to 0, and it is 1 when x is equal to 0. So you can check the left hand limit and right hand limit, but you don't need to here, because you can directly use the limit whether it comes to 1 or not. That is, at x equal to 0, the value of the function at x equal to 0 is 1. So let us see whether we get the limit or not. If it is mismatched, it is not matching, it is mismatching, then you don't have to worry about finding out the left hand limit and right hand limit. 1 minus cos x divided by x square, this is fx, and fx, which is x equals 0, you get f0 as 1. f0 is 1. So 1 minus cos x by x square, we'll use the formula. We know that 1 minus cos x, because 1 minus cos 2 theta is 2 sin square theta. 1 minus cos 2 theta or 2 cos 2x is 2 sin square x. So 2 sin square x. So when it is x, 1 minus cos x, it is 2 sin square x by 2. Okay. So just write it as 2 sin square x by 2. And since we have a proper formula like this, 2 sin square x by 2, this is x square in the denominator. Now we know that just now we have seen sin theta by theta, limit theta tends to 0 is nothing but 1. So how can we make it? 2 sin square x by 2 and divided by x by 2 whole square. X square is also already there. In order to make it as square, 2 square is 4. So you multiply and divide by 4. So you get 2 by 4 here. And this is sin x by 2 divided by x by 2 whole square. Same thing here. Now let us apply limit x tends to 0 here. When we apply limit x tends to 0, sin theta by theta is 1. So this is 1. So you can just leave all the right hand side things, because sin theta by theta is 1. We are only left with 2 by 4. Okay. So 2 by 4 is 1 by 2. Since the limit is 1 by 2, but the value of the function at x equals 0 is 1. They are not matching. So the function is discontinuous at x equals 0. If you have to show the continuity, follow left hand limit, right hand limit concept. If you just have to show discontinuous, follow this option. Next one is show that this is discontinuous. So you can again do the same way or apply the left hand limit, right hand limit. It's up to you. So fx equals f2, x is 2. What is the value here? X is equal to 0. Sorry, x equals to 0, it is 2. So when f0 is 2, the left hand limit, right hand limit should be what? It should be 2. Let us see whether it comes or not. So this modulus or absolute value is a machine. That is a machine. When you put any negative value, it will produce always a positive value. So left hand limit and right hand limit we are going to see. What is left hand limit? X is not equal to 0. We'll use this. So x is equal to 0 minus h and x is equal to 0 plus h. H is not equal to 0, but it is 0. It is so small. We can, that is why we are placing it as a limit. Limit h tends to 0. So we'll use this first one, x minus the modulus of x divided by 2. 0 minus h minus modulus of 0 minus h divided by 2. Here also 0 plus h minus 0 plus h divided by 2. 0 minus h. 0 minus h is negative h, and since it is a modulus absolute value, it will give you a positive value. It is negative h only. This is the first one, divided by 2. Minus h divided by 2. Okay. Now the next one is 0 plus h minus modulus of h. So positive value will give you positive value only. That is modulus. So 0 plus h is h minus h. It is not negative. Oh, there is a slight mistake. I'll just change it. See, it is h minus h, it is 0. Right hand side, it is 0. So just there is a correction, okay. Left hand side, minus 2h by 2 is going to be h minus h, that is 0. And 0 by 2 is 0 only. Okay. So you get a 0 by itself here. And here when you apply the limit, because h tends to 0, it will be 0 only. So 0, 0 on the left hand side and right hand side. So we have a 0 and 0 here, that is left hand limit, right hand limit are equal. But the problem is the value of the function at x equal to 0 is actually 2, which is not equal to, means these two are not equal. So you can just say that it is discontinuous at x equals 0, right? So this value at function and limit, they are not matching, though left hand limit and right hand limit, they are matching. This question we are going to see in the next discussion, or let us see this one also, okay? Let us see this one also. So this is what we have done already. So f(x), that is x equals to a. So fa is 1, it is already given. So now this left hand limit, right hand limit should come equal to 1 for continuity, otherwise it will be discontinuous. So left hand limit, right hand limit will use. At x equals to a, will check. So x will put a minus h here. X equals to a plus h will put in here. Okay. So you have this. This is the modulus. Modulus is a minus h I am putting. A minus h minus a divided by a minus h minus a. This is the first thing. Then we have an a plus h minus a by a plus h minus a. So a gets cancelled, it's negative h. So its modulus will be positive, minus divided by minus h. Here you can cancel this, h divided by this, also you get cancelled, h. So this is 1 and this is going to be negative 1. So minus 1 and 1, they are not equal. So you don't have to go even to check whether the value of the function at x equals to a is what, because left hand limit and right hand limit, they are not matching. And when they are not matching, you can say that this function is discontinuous at x equals a, right? Okay, this we'll take in the next discussion. So then, thank you so much. Take care of yourself.